Okay, we can start now. Once again, welcome everybody to today's webinar. The topic for today is management of manufacturing processes in the Windchill application. So let's look at the agenda for today. I'll do a quick introduction of myself and the company, go through the topic of digital thread, and then I'll just share a topic overview for our discussion for today. And then we'll do a live demonstration of the software itself. And then at the end, we will handle the question and answer session. So if you have a question at any stage of the session, please type it in the webinars questions section, and we will get to that at the end of the session. My name is Ifram Poyeng. I am a certified Windchill implementer and trainer with over 8 years experience on PDC products, specifically the Windchill or the PLM tool itself. And then a bit about the company. We are PDSVISION, formerly known as Boundary Systems. We just a little history about the two companies. Boundary System was founded in 2006 in Ohio, Cleveland. And then PDSVISION Group itself was founded in 2008 in Sweden. And then Boundary Systems became a PDC preferred partner in 2009. And then it also extended its footprint to South Africa in 2014. And we were acquired by PDSVISION Group in 2018. So we are now formally called PDSVISION. So we are the technology leaders in this industry, the first PDC global reseller and the preferred supplier. We offer software solutions for design and manufacturing teams or companies. And we also offer consulting implementation services where we go in and implement the tool itself, support it, and also involved in the upgrade and the other services that goes with it. We also offer professional training on all the tools that we sell. And we also offer the cloud solutions for the companies that doesn't necessarily have to manage their IT or get the IT to manage their PLM solution. And also a help desk. We offer help desk solutions on that. And all the companies that are part of PDSVISION, if you look at the map on the right here, that is where they are all situated. So we basically cover most of the time zones in terms of the help desk and the support of the tool itself. As I've mentioned, PDC is our main partner, but we also partner with other solutions companies to make sure that we offer our customers a comprehensive solution that meets their daily needs. Going back to the concept of digital thread, so digital thread is basically linking all product development data from start to end. Start meaning acquiring requirements at the very beginning, going through the concept design, the detailed design phase, the manufacturing of the process, and eventually the servicing of that product once it's out in the field. So to sort of implement a PLM system that covers this sort of digital thread, this is what we've come up with as a way of implementing the solution. So at the very start, most of the customers would start by just managing their CAD and documents in the system, your requirements, for an example. And then as the product matures, you then start looking at things like change management, managing change management in this one system. And once that sort of grows as well, you then start involving the things like manufacturing process. And eventually, you can sort of monitor the product as it is out in the field. And based on the feedback that you get about how the product is being used and how it's behaving in the field, you can sort of feed that information back in the system. And when you developing in the next level or the next generation of that product, you can basically apply those to make sure that you get the proper solution out. So in today's session, we will be covering the BOM management as well as the manufacturing processes on this. And then I mean, if you look at the flow of this data, this digital information data, basically this is where you start on the planning, the requirements, the design concept, and then the detailed design. And this is sort of information that's called an as designed information. So this is your mBOM sort of information, and then that information sort of ties with your manufacturing bill of material. That basically captures your as build. So you basically build that mBOM from the as designed information. So it's linked, and in that way, if something changes upstream here, it sort of flags you downstream on the mBOM that there is a change on the mBOM that we need to also pull into our mBOM view of it. And then lastly would be the as maintain, or they would also call it the as BOM, the service BOM of the product that basically houses the service information of this particular product, identifying what components are serviceable and what sort of component would go with those serviceable components. So things like training manuals, the service manuals, and the user manuals, and so on. So all this data is linked. Whenever any of this section changes, the affected sections gets flagged that there is a change upstream. Right, so the topic for today, we're looking at the manufacturing process management. And so what we would cover is the transforming of that engineering, or the mBOM, into the mBOM. And I mean, the reason for that is how you design the product. The focus is just form, fit, function. It's totally different how you go out and manufacture a product or even assemble that product. So the structure of how you assemble it will basically look different. It might even have more things that are needed to be able to build or assemble this particular product. So normally the mBOM view of your product will always be different to the mBOM. And then we'll also create the process plans, basically how we would go in and assemble a product. So in a factory or shop floor, how you go in and manufacture this product, what stages are involved, and how you basically set the stages and assign resources to different stages. That's something you can do in the system, and eventually generate a work instruction out of this. So once I've put in my process plan and I've assigned resources to it, whatever that's needed at every station, I can go in and export out the work instructions in a PDF format out of that process plan as well. Obviously, the benefits for managing your process information in the same system where engineering information is managed is that it will reduce time to market, in the sense that the manufacturing team does not have to wait for engineering to release that data before they could start with the manufacturing processes. They can do that as soon as the mBOM is available or the engineering information is available. They can already start on that at the very same time. And obviously lowers cost if there's change. So it's easier to maintain change if it is done earlier in the process. So we haven't purchased materials to build this. We haven't purchased components. It's still at the early stage. If there is a change, it's picked up quickly. And if it's in the manufacturing creation, manufacturing BOM creation, the engineering can be notified of that change and they can basically go in and implement it if it affects them. So yeah, that improves ramp up and productivity, because you basically start almost very early in the process to build your MBOM, and because the change is sort of taken care of at the very early stage, this will definitely reduce scrap and rework, because at this stage we haven't really bought the complete materials that we used to build or manufacture the product. Right. So these are the challenges that are there if you don't have this sort of processes where the engineering and the manufacturing are working on the very same data. Is that your design team lacks visibility into the manufacturing processes. If something changes in the manufacturing side, they would normally handle it that side to make sure that they get the product out the door, and they don't notify the design team. And what happens in those cases is the next generation of that product, the very same issue is gonna resurfaces, because it is not addressed properly on the engineering side. So engineering side will still produce the same mBOM with the same issues in that case. So because they don't have that visibility, it's very difficult for manufacturing to actually use or work with the engineering information, or they basically have to wait for that engineering information to be released before they can actually start. Yeah, so that is the second issue there, that it takes long to get from design to manufacturing, because before we can actually start, we need to wait for these guys to release, the design team to release, and if they're taking long to release, it basically delays our process as well here, and then eventually delays us getting this product out at the door. It's very hard to control planning information because we're not reusing these processes. Every time we're building a new product, we basically build the process plans for it from scratch, without the reusing, because all these processes are sort of stored in different systems, or in someone's local drive somewhere. And obviously, this one I've talked about is the disconnected change processes. The change that's done in the manufacturing could potentially affect or impact engineering or design, but because there is no connection between the two, manufacturing will just handle it that side, get the product out, and not communicate that change back to engineering. Whereas in the system where they're working with data that's coming directly from the design, whenever there's a change, they will look at things like impact analysis, and they would see that it impacts engineering as well. And in the very same workflow, in the very same process, they will be able to notify the design to make that change, so that they can also propagate that change into their manufacturing processes. And yeah, look, I've also mentioned this, like, we know if a change is done at that very late stage, it tends to be very expensive change, because we've already got material, we've already had components, but chances are we might have to retrofit those, scrap those, or rework them. Right, so the BOM management, or the work of BOM management, is to capture, for capturing, configuring, and managing all the product data that is developed throughout the life cycle. All information that is involved in the developing of the final product. The BOM management is used to capture that information and manage it, and ensure that there's also change management as well as traceability, also improved components and supply management. So if we've got this configuration, we can also add on top of it the supply management component, where we basically assign an approved supplier for this particular component. And we can also assign and say, this supplier has been blacklisted. We're not buying from this supplier anymore. So whenever we need this component, this will be the approved suppliers for it. This would be the suppliers that we've dealt with before. We had a bad experience, and then we have sort of blacklisted them. That information can be captured in the system, and everyone who's got visibility to the system would see and know which supplier to use and which one not to use. Right, so then this is the basic flow of it. So at the very beginning, the designers would, in any design tool, they would create the model or the assembly of this product. Then when they push it into the system would then create an e-BOM of it, because there's BOM management you're talking about, the e-BOM of it. And from that e-BOM, we can then create an mBOM format, and other BOMs like the service BOM that we talked about. And then again, the other thing is this BOM information that you see here could be pushed directly into your ERP system from here. So you don't have to have this assembly and then again go into an ERP system and manually create a bill of material for it. So the bill of material structure that you have in the system can be pushed as is in the ERP, which saves a huge amount of time in creating this information manually. So for today, we'll be focusing on the e-BOM, mBOM transformation of that mBOM, of that BOM, right? And just to expand a little bit on the e-BOM, so e-BOM basically captures the design information or the design BOM as design BOM of your configuration. So everything that has to do with design or the e-BOM, this is what gets captured. And as I said, when you check in your CAD model, so this is the representation of your CAD model. So as you check in this CAD model here, it will automatically create this BOM structure for you. The good thing or nice thing with the BOM structure is I can go into this structure and then link all the data that is related to this product. Things like the specification document, the requirement document, any information that's related to this product can be linked to this particular structure. And then also things like the substitute and alternative parts can also be linked to this. So I can pick the component and say, okay, in a case where we don't have this particular component to assemble this product, we could use this as a substitute for it. That sort of configuration can be maintained in that BOM structure. And then yeah, so the mBOM then simply contains all parts and assemblies that are required to complete a complete product, a shippable product. All what's involved in it, will then capture in the mBOM. So this is the e-BOM. We only worried about form, fit, and function, not how you would manufacture it. But then the manufacturing team is worried about how you go ahead and put this together, assemble this together, for an example. So yeah, you can go in and change the structure to meet how you would go in and assemble this, for instance. And the system allows you to do that. From that e-BOM, I can create a copy of that e-BOM, which is the design view, to have an mBOM, which is my manufacturing view here. And I can go into this manufacturing view and then move components around to meet how I would assemble this, for example, or I would manufacture it. So this is just an example of a motorbike assembling process here. So in an assembling line, on a floor assembling line for this motorbike, in the first station or line, we could have a frame, and then once we're done with the frame, we move it to the next station on here. And on the next station, we'll find the fork assembly with the front wheel already assembled to it. Then we basically assemble that frame to that. And then in the next one is basically assembling the suspension as well as the rear wheel to it. And then on the next one, is basically the powertrain for this, the engine, exhaust, fan, whatever that goes into the powertrain assembly. Do that on the next station, and then the next station is where we go in and assemble the hand control system, and then eventually the body panels to it to have a complete motorbike. So if we're looking at this is something you can do in the system. I can create a process plan, and in my process plan, I already have these different stages that tells me, okay, this is where I assemble frame to fork, assemble the rear, the suspension and the rear wheel, powertrain installation and control installation, and then I can then go into this particular operation in this process plan and assign what goes into that stage. So for an example, on the first stage, we would say this is where the frame goes. On the second stage, we would say this is where the fork and the wheel assembly would go. And on this particular operation as well, we can go in and assign the resource to it. I can say I need an assembler on here, and I also need an assistance to assist this assembler. If I've got, obviously they will need tools as well, screwdrivers and stuff like that. I can also assign those sort of tools on this operation here. Same for the different operations. And then at the very end, once this is now completed, I can then generate a work instruction based on this. So on every operation, what I can also do is I can specify the instructions for that operation. Use these tools. This is how you'd use it. That's step number 1. Step number 2, this is what you need to do. That sort of detailed information I can include as part of that operation. And then I go in and then I generate a work instruction out of this. My work instruction will have this different operations to it. And then for every operation, it will show me exactly what items or part numbers you would need on that operation. For that operation, it will also specify the resources, human resource or whatever hardware is needed or tools that are needed on that operation, and then basically print that as a PDF. Then the other thing I wanted to mention is with this sort of operations, some of this could be reused. So if I am assembling a different motorbike, that would maybe require an extra 2 steps for its own process, but some of the first 3 processes are exactly the same. I can reuse these 3 processes in that process plan, and then just add additional steps for a different motorbike or a different product. Okay, so with that said, I'll jump into the demonstration of the tool. So I'm using a system called Windchill PLM here. So Windchill, for those that haven't seen, Windchill is a web-based system. So any browser could be used to access the system. What you simply need is the link or the URL to that system, as well as the your username and password, your login credentials to that. So the server itself gets installed on a hardware server or a VM server with certain components that goes with it, like the database, application, web server that goes with it. And then for the user end, this is that you all that you get. Put in the URL, punch in your username and password. This is the user that I'm logged in as, and I am on the landing page of Windchill. If I click on the home icon here, I get different tables on this page. The first table is my workspace tables. This is the tables that's table information that's been used by the designers, the engineers that design the actual product in CAD. So the function of this workspaces here is to simply interface Windchill with the CAD tool, Windchill with Creo Parametric, Windchill with SolidWorks, Windchill with Inventor, so that they can communicate. You can push information into the system, check it out, modify it, push it in, create new information, reuse, that sort of thing. They would use that to do that. Then you have the My Tasks table. So this will list all the tasks that are assigned to you. If I am an engineering manager and there is a task for me to approve the release of my drawings or the release of my assembly product, I will then receive a task that says I need to go in and approve. If I'm a reviewer, I'll receive a task that says I need to go in and review. And if your system is linked with your email system, you'll also get the task in the form of an email with that details that there's something that you need to, or there's a process that you need to approve in the Windchill system. And then the last table on here is just to show you work that's checked out to you. It might be that someone needs to work on this stuff, but you have checked out this assembly that you have checked out, but they don't have access to it because it's locked out to you. No one can modify it at that time. They can still see it, access it, open it up, but they won't be able to check it out and modify it. So they'll probably ask you to go in and check that file in before they could work on it. This is stored somewhere in the system in the folder, and I'll show you that in a bit. But if you don't want to go through that, or you're not sure where it is, you can simply come to this table here. And from here, I can either do checkout, I can go to this particular file from here and check that file in. Okay, and then at the very top here, I've got what you call a simple search. I can go in and specify the type that I'm searching for, whether I'm searching for a CAD document or I'm searching for a document, like a Word or Excel, and I can go in and put in a keyword for it. So I'm searching for something that's got a motorbike in it, for an example. It will go and search the system where I have access, search for this motorbike keyword in it, and I see it didn't find anything in this case. It's simply means I don't have anything that starts with motorbike. So I'm just gonna change this search slightly here. Rerun it again. Just search for something with motor in it. So I've searched for something that's got motor in it, and I'm searching for CAD document, which is a design file. I'm searching for a document like your PDF, your Word document, and I'm searching for a part. A part simply means a product structure, either mBOM or mBOM that I'm searching for there. And then it will then return my results. The other thing you can do with the system is, if you don't really know the number or the name of that component, but you know how it looks, I can hover over this thumbnail over here, and then it'll basically bring me an image of that component. So I can interact with this and see if this is what I'm looking for. So this is the motorbike that I'm looking for. These are the details of this motorbike. These are the items that are used in this motorbike to make up this complete motorbike. I can also see those directly from here. So if I am someone in manufacturing who doesn't have access to the CAD tools, SolidWorks, to Creo Parametric, or if I am a reviewer or an approver and I need to be able to look at this, I don't have a license for a CAD, I can simply open this in what you call a viewer, a Creo view. So every user who's got access to Windchill would have a Creo view license. It's a tool that would open up here. It asks me to log in on a different screen. Once it opens up, I'll bring it to your screen here. So this is the motorbike that I've opened. So I can simply go in and just load this in this viewer application. It's basically loading this. So there you go. It's loaded my motorbike in this. So if I am a reviewer, I can look at this, and then if I've got any comments, markups, red lines, I can capture that. So I can simply go in and say, all right, so this fuel tank here, maybe we should change the material on this. I can basically communicate that information by redlining this. I can go in and change material to whatever material code it is. save this information, and I can then go back and save this as an annotation back into the system, so that it's available to whoever that needs to go in and do these changes. That's I mean, a whole lot of things that I can do with this. So for instance, I can look at this particular rim here. If I want to look at the diameter of this rim, for an example, I can do that. So think of someone who's on the shop floor where the drawing doesn't really show some of the information on the model. So they can simply open this 3D model in a big screen in the shop floor and basically get this information directly from here. So this is sort of information you can simply get on here. So those are the sort of markups that you can use for this to get that sort of information, right? So yeah, that's the 3D tool. So I'm not changing anything in terms of design. I am just adding red lines to it. That's all I was doing. So the system allows you to do that in the system. And then if I go into any of this as well, I can go in and look at additional attributes of this. For instance, I can look at the life cycle that my product basically follows. At the moment, it's in work, meaning I can modify it, make changes to it, and so on. And once I'm done, I can go in and promote it for approval. And then once it's approved, it will go to released. And then once it's released, it gets locked in that release state. No one can change it. If you need to change it, you'll basically need to follow a formal process of revising this process. If you revise this, it will then change that revision, which is now at A, from A to B. Okay. And then it comes in new revision, it goes back to the in-work state, and then you can start with your modifications. And once you're done, you then release it again. Okay. Right. So then the other thing I wanted to mention here is this is just an out of the box life cycle of this product. This can be changed to meet your business processes. Most customers would have this as a design, for an example, and then from design you go to prototype. From prototype you then go to production, and so on. So you can include those as part of your processes in there. It also shows me who's modified this item, and then when it was last modified as well. The other thing is I can also capture additional or custom attributes that are not captured as part of the default attributes. I can go in and create those custom attributes that we use in our company. So things like description, material, and weight. I can capture this information, and as the designer checks in this 3D component, that information could be pushed automatically from the CAD application directly into the system. So I don't have to manually add this information here. I can actually automate the push of that information, but it's already available in the 3D tool. So that information can simply be pushed into the system. The other thing to just show here is the how information is stored. So Windchill stores the information in what we call contexts. So this is a product context. Product context simply means this would store information that's related to a specific product. In this case, it's a KTM motorbike. Information will be stored relating to that KTM motorbike. And then you also have a library component. So I'll just talk about this too. The library components just stores information, items that can be reused. So things like nuts and bolts that could be reused across most or all products. And then for every product, if I expand it, I've got the folder view of it, and I also have a team. So a team, it simply shows me the roles as well as the participants for those roles that will have access to this product. So these are the roles for this product. For instance, a product manager, and then these are the two users that I added to that product manager. I could also have a role called guests. So if I need to give someone access, read-only access to all the data in this product, I'll give them the guest access, and then they will be able to view information, but they won't be able to modify that information. So there's different roles, and this also can be customized to meet your business processes. So the one thing I talked about was the folder. If I go to the folder context here, or the view context, this takes me to the part where the actual components that I've searched for, I've shown you, resides. And in here, I can further organize my structure by creating subfolders in here. So I've got a subfolder for CAD, for an example. This houses all my CAD items in it. So my Creo, SolidWorks, so Inventor data will be stored in here, including my eBOM and mBOM. Documents, I can go in and store my documentation in here. Things like in this one here, you can see I've actually stored an Excel file in here. And it's got a number, it's got a name, a version for it, when was it modified, and who actually modified it. Okay, that is the Windchill interface in a nutshell. Now I'd go back to the topic of the day, which is the creation of mBOM processes or manufacturing processes. So I've got an assembly here on the side here. I'm going to quickly show you how you go in and create a manufacturing the mBOM view of this. Yeah, so to do that, you basically go into something that they call a BOM transformer in Windchill. So what BOM transformer will do is, on the left-hand side, it will show me my eBOM, my design view on that side. And then the right side, this is where I will build my my mBOM. So there's a couple of things to note on here is you have what they call status indicators here. Status indicators simply shows when there is a link of eBOM to mBOM. If there is a disconnect on that link, it would also show you that. And it also shows you, in this case, with this yellow triangle, it simply means at this stage there is no equivalent link of this on the other side. So I'll go in and start the creation of this. There's a couple of ways to do this. If your intention is to go in and create an mBOM or a view, and then you want to completely change what goes under that mBOM, you would go in and create a manufacturing view that does not duplicate. So you'll pick that option that says do not duplicate. What it will do is create an equivalent top level item as a manufacturing view without anything below it. Then you can go and restructure the mBOM the way you want, and you can copy or move items from this side into the restructured view of this. The second option that you get here is the duplicate with propagate. What that simply does is you just go in and create a similar view to design, but of manufacturing view the side. The very same view that you see the side, you'd create on the right hand side, but with the manufacturing view. Then you normally use this one if you are going to be modifying or making changes to the items or part numbers on the manufacturing view, and you create that copy of it because you don't want to make changes to the design. Then the last one is propagate without duplicate without propagate. It will create a top level for manufacturing, and then it will just keep the design for the sub components on the left. So it will just reuse the designs. You normally do that if your manufacturing process looks exactly the same as your design process. If it's exactly the same, you then use this option here. So I'll go in and just maybe explain the other attributes here. So the BOM or the mBOM that you're creating could be for different reasons as well. Could be just for costing, could be for testing if you need to prototype something and you want to create a BOM just for that, or it could also be for production as well. And then I can also create alternative BOMs as well. So if I have different plants in different areas, And then the way this particular assembly has been assembled in just different plants is different, or is going to be completely different. I can go in and create an alternate mBOMs for those, and then similarly create different processes or process plans for those as well. I'm just gonna leave those as blank for now. And then I just want to show you all the different ways of creating this. So the first one is with do not duplicate. Go in and recalculate and then create that. As I said, it just creates the top level link only. And then you also see the status indicators as well. It shows with that green tick that I have created the equivalent links between these two. And I can go in and create whatever I need below this, as maybe the sub assemblies for my manufacturing bill of material, and then go in and copy some of these into those different sub assemblies. So that is the function for that first process. I'll go in and show you the second one. So I'm gonna take this sub assembly on here. So this is my sub assembly. It's got like 4 sub components under it. I'm gonna go in and open this in BOM transformation. Right, and then I'm going to go in and create a manufacturing view using the second option, which is duplicate with propagate. Go ahead and create that. Right, so you see the difference. The difference is it's created the very same structure, but the view is different, is manufacturing. So I would normally do this sort of thing if I am going to be modifying this, checking this out and checking it in. I will do this because I don't want to interfere with what is on the mBOM side. Then the last one I would show you with the last subassembly here. So the last option would be just go in and create the same thing, but in this case is duplicate without propagate, which means I'm creating a top level manufacturing and I'm just reusing the sub and components as is. I'm just using the sub components as is. So there is 3 ways of doing it, and normally you do this sort of setup if the manufacturing process looks exactly the same as how the design, the BOM has been configured or has been built. You'd basically use this, because if I change this on here, if this gets modified on here, it will automatically update obviously on here because it's the very same component. Okay, and so those are the 3 ways of creating the bill of materials. So now I'll go into the one that I've already started working on for this particular demonstration. So this is the motorbike that we've created. I've already created the manufacturing view of it. So I'll show you the difference between these 2 views that I've done here. So you'll see everything is checked. It means they're all linked on different sides. But what you'll see is if I go under the chassis assembly, which is this one here, you'll notice that this is sorry, the wrong one. Chassis assembly. Yeah, you'll notice that this one and the one that I have on the manufacturing side is actually very different, because how we would assemble that chassis is going to be different. So I've moved components around the bed, because how I'm going to do this is I'm going to first assemble the fork and frame assembly. I'm going to take the fork and just go to visualization here. Because how we're going to build it, assemble this is we're going to put this 2 together first, and then from there we'll add the rear suspension, then the rear wheel, and after that we'll then have a complete chassis assembly in this case. So you'll see it's totally different to this. So on this side we've basically done it exactly how we would put this together. And then you'll see the other ones are still on the very same level because those would follow as these. We don't need to make any changes to those. In fact, we could have used this as is from design because we're not going to be modifying it. Right, then from here, I would go in and create a process plan for this. I have one that I've started working on, or started creating, but I'll quickly show you how you would go in and create one. So I was just clicking on that new process plan, insert new process plan. I'll go in and specify what this process plan is for. This is for production, maintenance, quality check, or for repairs, which is for production, and then you give it a name. You'll give it a name, a description if you need to, specify the view for it as manufacturing, because it's manufacturing. Then you basically click OK. This is how you simply create a process plan. So I'll go into mine that I've already started creating here. Yeah, this is our process plan. And then what I have done in the process plan itself here, I went in and created my operations. These are the operations. So think of these operations as what you will do on different stations in our flow. And so the first one is to assemble the chassis, and then I've got sub operations for this as well. Because we know, firstly, we need to assemble a frame to a fork assembly, and then from there we need to add a suspension for it, and then we need to add a rear wheel to it. This is the first operation as well as its sub operations. And what I can also do in here is I can also specify a station. So this is basically a station where this would happen. And then on this operation, I can also go in and specify the resources, the human resource, skill, assembler, for instance, an assistant. I can simply go in. So I can go into this one here and then pull up my resource information. And to quickly explain the resources here, I've created a plant, call it just Cape Town plant that I have in here. And then my plant here, it's got this stations in it or lines in it. It's got a feeder line here. It's got an assembly line number 1 up to number 4. And number 4 being the inspection line there. And then on every line, I've also added a human resource or a skill to it. So for instance, for that one, we'll need an assembler and assistant. And then on the third line here, where we would be installing the hand control units and lights, we will then need an electrician as a resource for that. And then the last one, we'll need an inspector. So this structure, it's something you can create in the system, build it up. I actually started building even a 3D view for it as well. So for my feeders, this will be a 3D view for that feeder, and then on the slide here where I do the inspection, I've got like a rail sort of thing where this motorbike will be tested on. And it is not complete at this stage, the whole plant, but you can have either a plant layout, as an example, 3D layout for it, or a 2D layout for this plant, and then have different 3D representations of your lines or your work centers or your work units and workstations also specified in there. So I can simply go and say, all right, for this, we basically need an assembler. I just drag and drop that assembler in there. We'll also need an assistant. I'll go in and just drop and drag the assistant in there as well. Inspector, for an example, it's happening at this particular line here. And then I can also go in and say, this is the resource that we would need for that. And I can do the same for the other ones as well. The other thing I can do, so this was just on a station, assigning a skill, assigning an operation to it. And the next thing I can also go in and do is go and assign a part numbers to a particular station. So for instance, for the powertrain assembling here, I can go in and assign the powertrain components to it. By just simply drag and dropping that in there, those are added on those. It then shows on my BOM as well on the side here, and then you'll also see on the image of my complete BOM, it also shows the consumption. It shows that those particular components has been now consumed on my process plan, and they sort of get removed from that viewable as well. And I can see also what is still remaining on there to copy and move onto the process plan itself. When I'm done with the process plan, I can simply go in and check this in. Check everything in, and because as I'm bringing in these items into these operations, it adds the visualization to it. I can also go in and create the visualization for different operations. So I can go in and create the representation for this. Once I've created that representation, I can go in and create an illustration for this. So add information that I need to communicate to to whoever that will be using this work instructions. For an example, if I were to go back to this initial one that I've already started working on, I can simply go in and modify this. So edit representation on this, and then it goes and opens the illustrations that I've already started working on. It's just opening on the side. Once it's open, I'll bring it this side. Load it. Yeah, so once it's loaded in here, I can simply go in. This is the illustration that I had started working on, but I can simply go in and add markups to this. So go in there and say assemble frame to fork assembly. Take that information, save it back. So that is the information that I'm trying to communicate to on my work instructions. Once I'm done with that, I can simply, just to show you the output up to now, I can simply go in there and just generate a work instructions for this. Right, and you'll see this is my work instructions. It's got information about the process plan itself, and then it's got different stations. This is the first one, the feeder line, and this is the one that we've just modified. It's a little, the text is quite small on here. I could have increased the text, but this is the illustration that I've just created now in Creo View to add that note on there to just communicate this information on my work instruction. And on that work instruction, I can see these are the parts that are located at this station, so which is that fork assembly at that second station. And if I scroll down, I haven't created variables for those yet, but I can see that at this station, I would find the rear suspension assembly, and then these are the resources that will be needed for this particular stage. Same applies to the other ones that we've created as well here. Those are the list of parts that are needed for this particular operations. And if there were resources, just going to list the resources as well on there. And then once you've created that illustration, it will also show in here. Now from here, I can simply go in and print this as a PDF, and then share it on the shop floor. Print this as a PDF output, and then simply just share it on the shop floor. That is basically the process of creating manufacturing in there. And again, just one thing maybe to just simply show on here is I can also have a playback on this that simply shows me the complete process of this assembling. So it shows me on this one, we basically assembling the rear wheel. And the next one, what it's doing. So it basically shows you the whole process of assembling all the components that we have in this up to now. And then eventually at the end, once we've populated all our process plan, it would give us a complete a motorbike. Right, that is all I wanted to show as far as the manufacturing process is concerned. And at this stage, I will go back to my presentation and maybe look at the questions if there's any so far. Okay. Yeah, I see there's no questions at this stage. So I'm just gonna say, if you have any questions post this webinar, you can email any technical questions directly to me at ipoyeng@pdsvision.us. And if you have any sales query, you want to have a demo on a specific part that I've showed, or any PLM component that you're interested on, you can email sales@pdsvision.us. Any information, you can visit our website, pdsvision.com, or also visit our YouTube channel for other webinars that we've done in the past. And if you wish to also come back and rewatch this particular webinar, you will be able to do that. It should be uploaded into our YouTube channel in 2 days' time. If there is no questions, I would like to thank everyone for attending today's session, and enjoy the rest of your day. Thank you.